In the video today, we're going to talk about Triangle Midsegment Theorem and median and centroids. So what does the term midpoint mean? Doesn't it mean the halfway point between two ends? So we could say halfway between, we could say 2 points, right? Halfway between 2 points. Okay, so if I got this point and this point, I draw a line between them, then I'm looking for the part that makes this equal on each side, right? So now that's equal with that. Can we agree on that? If we find the midpoint, okay? So again, it's a point, in essence, right there, that cuts the big part in half, okay? So a midsegment of a triangle is a segment that joins the midpoints of two sides of a triangle. So let's just look at this side over here, QP, okay? Notice that this point right here is the midpoint of those two sides. Thus, we have that QX and XP are congruent, right? So it cut them into two equal parts. So if we talk about that side, and then we talk about its midsegment would be, actually, let's just keep drawing these, okay? We'll keep finding these midpoints, and then we'll talk about the rest. And we'll talk about how they relate, okay? So this next one is PR here, right? Again, so if we find the middle point of that, then we have that this segment PZ and ZR are congruent. You'll see that? Then our final side is this side over here. And again, if we find its midpoint right here, then we have, again, we cut that big point QR in half. We get QY is equal to YR. Y'all see that? Now, here's another piece of this that's true. The side that's parallel to the side in the triangle. So then when we draw these midsegments, okay, so the midsegment here, this one right here, notice it is parallel with QP. So that's a big point. So let's say PQ is parallel to YZ, okay? They're parallel, but also all three of these lengths are the same. So let's just say this side over here was, let's just say for the sake of, let's say if this was 3 and this was 3, then that means that length right there is 3. Y'all see that? Okay, so our midsegment in this one was YZ. Yes, that's one of our midsegments, okay? So now let's keep talking. So notice again, we have the PR and we have PZ is congruent with ZR. So this right here would be the midsegment that is parallel. So this one is PR is parallel with what? XY, right? And notice again that this, if we said that this was 4 and this was 4, then the whole length would be 8, and this up here, this length would be 4 as well. So I'm going to show you the pattern in a minute after we get finished talking, but I want you guys to notice that. Now our third side again, oh, and let's just go ahead and make that one. That one was what? XY. So our next one was XY. Okay, then our last one, notice we got QR. Again, the midpoint of that is Y, and then we got QY is congruent with YR. So again, the parallel side, so we have that QR is parallel to what? XZ, right? Okay, those are parallel. Should have put line segments over these, y'all, but symbols. Okay, so then notice again that if we said that XY was 5, let me see. If we said that this was 5 and this was 5, then we know that this is the same, right? This is also 5. Okay, so now let's talk about what we see about these relationships, okay? So do you notice that this whole side here is what? Isn't that 6? And then this segment right here is half of that, right? So if we had the whole side, it would be 6. Same way down here, right? So what is this whole thing right here? It's 8, and then its midsegment is 4. So that's half of that one, okay? Then we have this one up here we said was 10, right? So this is 10, and that is 5. This one right here is 5, right? So its midsegment is 5. So our final midsegment, by the way, was Z, okay? So midsegments of triangles XYZ are these: YZ, XY, and XZ. Y'all see it? Okay. So the relationship shown in example 1 is true for the 3 midsegments of every triangle. So this is always true. So if we find the midpoint of sides and we connect those, then the midsegments are going to be half the side that's parallel to them, or equal to, yeah, basically the mid segment, okay? All right, so I don't know why I have that written twice, but that's okay. All right, so here again it says the midsegment theorem, a midsegment of a triangle is parallel to the side of a triangle, and its length is half the length of that side. So in other words, if we were to talk about this side right here being, well, let's just say what, 12, then DE must be 6, right? Because it's half of it, okay? So again, this was the midpoint of side AB. This was the midpoint of side BC. So the midsegment of those two sides is DE, okay? And it's going to be half the length of the side it's parallel with. Got it? All right, example 2A. Using the triangle midsegments theorem, find each measure BD and the measure of angle CBD, okay? So, and we're going to be able to talk about that based on the things that we already know, okay? So this is asking me to find the length of BD, and BD is up here. So we want to look at the side that's parallel. That's this side right here, right? AE. Okay, so what do we want to do? We want to divide this by 2, and we want to find each of those segments, because remember, all 3 of those are going to be congruent, right? So isn't that going to be 8.5 here, 8.5 there, and 8.5 there? Sure is, because that's half of 17. So that means BD is equal to 8.5, okay? So now we're going to talk about this angle right here, CBD. So we're looking for CBD, which is up there, right? So we're looking for this angle right here. So I want to see if I can find a pair of parallel lines that are going to help me find that. So notice here we have this side A. Actually, let me do this in a different color. AC is parallel with that side right there. So I'm going to put some parallel symbols on it, right? So now, do you guys see a pair of parallel lines that have a transversal? I do. Y'all see this transversal right here? So don't we know that this angle right here is congruent with that angle up there? Why? Because of alternate interior angles, right? So we know that angle CBD is congruent with angle FDB, right? Okay, so that means we can say that angle CBD, the measure of angle CBD, is equal to what? 26 degrees. And they are true because they are alternate interior angles, right? Alternate interior angles. Okay? All right, so the next one says check it out. So example 2A, find each measure. So go ahead and pause the video, come back to me when you're done. Okay, so this next one says find the length of JL. So where is JL? This is JL right here, right? So what do we know about JL? We know that these 3 lengths, this length, and this midsegment that's parallel to it are all the same, right? So that means that this is 36 and this is 36. So aren't we going to go 36 plus 36? And that's equal to 72. And the next one we're looking for is PM. Okay, that's PM. Now we know that PM and LN are parallel, right? Those are the parallel sides. So we know that this is 2 ticks, this is 2 ticks, and this is 2 ticks. So we're going to take that 97 and we're going to divide it by 2. And that gives us 48.5. That means this is 48.5. It means this is 48.5. And it also means that up there is 48.5, right? So PM is 48.5. And we divided that 97 by 2 to get that. All right, our last one says find the measure of angle MLK. So let's see if we can find the MLK. MLK is that angle there, right? So let's see if we can find some parallel symbols. You know, I'm going to erase some of the stuff so we can see it a little clearer. So I see another side I see a midsegment that's parallel to that, right? Aren't these parallel to each other? Okay, and then I see a line that cuts those right here, right? So this line right here cuts those parallel lines, right? So it says that this angle up here is 102. So isn't that angle right there 102? Why are they congruent, y'all? Because they're corresponding angles, aren't they? So let me write that a little clearer. So this angle was also 102. Come on, pen. 102, and that's because they are corresponding angles, right? RESPONDING. these angles were corresponding angles. This angle would have been congruent with that angle, right? Because they are on the same side of the transversal and on the same side of the parallel lines. All right, so this next one says indirect measurement application. So in an A-frame support, the distance PQ, okay, so let's go ahead and draw PQ because it's not on here, right? The distance PQ, it says, is 46 inches, right? In an A-frame support, the distance PQ is 46 inches. What is the length of the support ST if points S, so that it's telling us this is a midpoint, right? That's a midpoint right there. It's also telling us that this is a midpoint over here. So that means that segment up there has to be what? Half, right? So this time we know that ST is equal to 1/2 of PQ because they're parallel sides, right? Aren't these parallel? So it's half of 46. So ST is equal to 23, right? Inches. Okay? So remember, if their sides are parallel, then if we'd had a midpoint down here, right, it would have cut this in half, and that would have been 23. That would have been 23, and obviously that would have been 23. Okay? All right, check it out. Example 3 says, how many meters will she measure between H and F? So basically, this looks like a crater of some sort, y'all. And it has that this is meters, so I'm actually going to put an M up here. This is meters, right? So it's asking us, okay, so you can clearly see, do y'all see that this is congruent? So that means this is a midpoint, right? These are congruent, so that tells me this is also a midpoint. So if that's a mid-segment, and how does it relate to its parallel side? All right, let's see if y'all can finish this. So can't we say again that HF is equal to 1/2 of AE, right? So HF is equal to 1/2 of 1550. So that means HF is equal to, what is that? Let's see if I remember, 775. So this is 775 meters, right? Okay. So the next check it out is a little bit different. So this one says XYZ is the midsegment of triangle. Yeah, what triangle? Huh? I guess it's XYZ. So this should say triangle XYZ. Sorry. What is the perimeter of XYZ? Okay, so now what does perimeter mean? Doesn't that mean all sides added together? That's what it is. Remember that perimeter? Okay. So what we need to do then is we need to use what we have. So we got, that this is 3. So that means this is also 3 and this is 3. So that whole side is what, y'all? 6. Okay, if that's 4, then that's 4. Then what's this whole side? 8, right? And then we got 9. So aren't we just going to add 6 plus 8 plus 9 for the perimeter? That's 14 plus 9, which is 23. Right? 14 plus 9 is 23. Yep. Okay. So the next one is a different term. So now we're going to talk about medians. Okay, medians of a triangle is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. So everybody listen. So the first thing we want to do is find this midpoint right here, and we know that because these two parts are congruent. So if we split AB in half, we get AD and DB, right? When we talk about this median, it goes from the vertex of the opposite side to that midpoint, okay? So we could draw one of these for all of them. So I'm going to show y'all again how I would do it on another side. So we're going to do it in different colors. So if I find the midpoint up here, right, then I say this is the same length as that. Then I'm going to draw that line to the opposite vertex, okay? We're going to do it for a third one. So this time again, we're going to find that midpoint. 1, 2, 3 ticks, 1, 2, 3 ticks. And this time we're going to draw that again to the opposite vertex, okay? So where those points come together, it's called a point of concurrency. The point of concurrency, that's this point right here where all 3 of those come together. We call that a centroid of the triangle, okay? So the centroid's always inside the triangle. The centroid is also called the center of gravity because if we actually balance the triangle on that point, it will stay balanced, okay? So And here's the rule, and I'm going to show you all this with numbers because I think it'll help y'all see it a little bit better. So it says the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay, let's just not make this complicated. Okay, so we're going to start really simple. So this is what I want to tell y'all. If the whole length of BZ right there was 3, BZ equals 3, then that would mean that from the vertex to the centroid would be 2, and from the midpoint to the centroid be 1. So do y'all see that ratio? From the vertex to the centroid is 2, and from the midpoint to the center is 1. So we're going to use this ratio for all of them, and I'm going to teach you guys how to find it, okay? So here again, let's watch. So let's just say I told y'all this one right here was 6, okay? So if I told y'all x c was equal to 6, then what we could do to find each of these parts is we could divide that 6 by 3, because it's 3 separate parts. Y'all see 1, 2, 3 right here? Okay, divide that by 3, and that gives us what? 2. That means that xp is going to be equal to 2. And then if we multiply that 2 by another 2, then that's going to give us pc. So that's 4. Now look, doesn't 2 plus 4 equal 6? Okay, now there's another way, again, to do it. Now, what I want you guys to see again is that the side from the vertex to the center is always twice as big as from the midpoint to the center. So what do I mean by that? Okay, so here we go again. So midpoint to center. If I told you guys this was 3, okay? If I told you this was 3, then this length over here from the vertex to the center is 2 times 3, which is 6. So what's the whole length? It's 9, okay? So there's another way to approach this. I'm going to show y'all, okay? So if we know the whole length here, again, is 9, y'all see that? 9 is equal to AY is equal to 9, and I want to find AP. AP is going to be 2/3 of 9, right? So 2 times 9 is 18, divided by 3 is, guess what? 6. Y'all see that? Then what does that mean? That means that bottom part is 1/3, right? So that's the ratio. So if we now said we wanted to find PY, that's going to be equal to 1/3 of 9. So what is 9 divided by 3? That is 3. So can you see that these two added together add up to be 9? Okay, so some of this you're just going to have to memorize, okay? But there's a lot of different ways to approach this. So let's just talk through this first example. It says using the centroid to find the segment length. So it says in triangle ALMN, RL is 21. It says this whole length right here, RL, the whole thing, y'all, is 21. Okay? 21. Okay? And then it says SQ is 4. Find LS. Well, we don't really need the SQ for this right now. So I'm just going to, that's kind of, for this part we're doing right now, we don't really need that. But it's asking us to find LS, okay? So it's asking us to find this length right here from the vertex to the centroid, okay? So this is the part of that whole line of 21 that we're going to find. So there's 2 ways you can approach this. Remember, it's we could say that 2/3 of RL is equal to LS, right? So that would be what? 2/3 times 21, right? So 21 divided by 3 is 7. 7 times 2 is 14. So 14 would be equal to LS. Now let me show you another way, but which will work better for some of y'all's brains, okay? So I could also divide this by 3, and that's going to give me 7, right? So that means that right there is 7, and then this other part is 2 times 7, which is 14. Another way to find it, okay? So now let's do example 1b. This time it's saying, gives us the same information, only this time it's asking us to find NQ, okay? So we have SQ, and it's asking us to find NQ, okay? So this time we have SQ. So we have this part right here, right? It's telling us that it's 4. Now, what did I tell you was the relationship of that 4 and the NS? Do y'all remember when I talked to y'all about this? Like this part up here What is the relationship? Isn't it 2 times 4? So that's going to be 8, right? So what is 4 plus 8? It's 12. So we could find NQ that way, right? That's equal to 4 plus 8, which is equal to 12. Now, here's the other way to do it, okay? We know that SQ is equal to 1/3 of NQ, right? We have SQ. It's 4. Sorry, I put 1/2. I meant to put 1/3, y'all. Sorry, my bad. So this is 1/3, because remember, it's from the side to the center is 1/3 of the whole. So if we do 4 is equal to 1/3 of NQ, how do we get rid of a 1/3? We multiply by its reciprocal, which is 3, right, y'all? So we're going to multiply this by 3 to get rid of the 1/3. So we multiply both sides by 3. So 12 is equal to NQ. Got it? So either way works. All right, you guys approach this whichever way you want and come back to me when you're done. Okay, so this one says JKL, ZW is 7. ZW is 7. Now that's from the side to the center, right? So don't we know then this has got to be 14? We do. Okay? So then it says to find KW. Well, what's 7 plus 14? 7 plus 14 is equal to 21. So once again, we could have said that ZW is equal to 1/3 of what? KW, the whole thing, right? So again, how do we do this? 7 is equal to 1/3 of KW. Multiply both sides by 3 again. So isn't that our 21? So 21 is equal to KW. 2 ways to do it, okay? All right, the next one says LX is 8.1, okay? So LX, that's the whole length, y'all. Let's do this in a different color. LX is 8.1, the whole thing, y'all. The whole thing is 8.1, okay? And then it says to find LZ. So LZ is from the vertex to the center. So we know that LZ is equal to 2/3 of what? LX, right? So LZ is equal to 2/3 of 8.1, okay? So this time, again, we could have divided 8.1 by 3 and then multiplied it by 2, but we're going to actually multiply this by 3/2. Actually, no, we're going to do that. Exactly, it's right up there. So divide 8.1 by 3 and then multiply it by 2. Or you can just do 2/3 of 8.1 in your calculator, and if I'm not mistaken, that's 5.4. LZ is equal to 5.4. Okay? That's it.